So we're going to take a look at a few different examples and determine the angles, or if there is no angles for the given information. Now, with this one here, it's a little bit, I would say a little bit difficult to do it on paper, like, or on the computer here, but we're going to do our best to try to draw it out as best as possible. So here we're given three pieces of information, and we're asked to find angle B. So we have little a, big A, and we have little b. Now, if you remember back to what we said before, okay, so in this case here, we're given an angle, we're given a side. This side here has to be longer than, and I'm just going to quickly plug it in, with b times sine of A. So A has to be greater than b times sine of A, and b times sine of A is, let's see if we can quickly get it up here, 7 times sine of 42 degrees, which is equal to, and I'm going to pull out the calculator here as it loads up, put in degrees, seven times sine 42, so it has to be longer than 4.68. And so this is 4.68, and 6 is longer than 4.68, which means that we're going to have two solutions to this. So when we draw it out, and I'm going to try to draw it out as semi-accurately as possible here, we'll usually start with kind of like a flat, let's see here, there we go, okay, flat, and then we'll try to draw this a little bit better here. Here's going to be our angle, 42 degrees, right about there. Okay, so there's 42 degrees right there. And then we're going to have our other, so we're going to have kind of our two measurements. We're going to have this one here. And we're also going to have this one here. Now, when I'm put in the numbers that we have here, this is going to be A. This is going to be C. And we're not too worried about C at this point. And we're going to have two different B's. We're going to have B1, and we're going to have B2. We're going to have two different measurements for B, and B1 and B2. Now, just to quickly put these ones in here, we know that this is a length of 7, this is a length of 6, and just to kind of speed things up a little bit, I'm not going to put in the 42 degrees, but we know that this is 42 degrees as well. Okay, sine law. I'm not going to write out all of sine law here just to save a little bit of space. Okay, because we're going to end up fitting some things in here. So sine 42 degrees, you know that one, over 6 is equal to sine of B. I'm just going to do B in there because we'll find B1 first, and then we can use that to find B2. And so angle B, we'll do 7 times sine 42, those brackets, divided by 6, and inverse sine of our answer, 51.32 degrees, and we're going to round it to the nearest degree. And so we're going to say this is 51 degrees. Okay, this is B1. Okay, so if we want to actually put it in here, let's see if I can. Let's make this really small for the time being. Oops, not do that. Okay, so this is B1. Okay, what I'll do is I'll put it in like this here. Okay, so B1 is like that. Okay, for B2, we just need to subtract it from 180. So that this one here is 51. There's my nice 51. And then this one, the other B2, so B2 is going to be, so to find B2, we need to do 180 minus 51 degrees. And so we're going to get a measurement of 129 degrees is equal to angle B, and it needs to be able to do a subscript here. There we go, 2. Okay, there we go. Still kind of learning this program a little bit. So that means B1 is 51 degrees, B2 is 129 degrees. Okay, and again, it's because A was bigger than 4.68. So for that reason, we have 2 answers to this question. If it's smaller, we've got none. If it's equal, we have 1. Okay, and then it's just a right angle triangle. Let's take a look at this second one here. Number 2, we're given DE, big E, and big D. Now, we have different letters, but we can just kind of manipulate, or we can use those different letters the same way we would here. You notice here we have A and big A. Here we have E and big E. So what we're going to say to start is that we want to double check, is E greater than D times sine of E. Okay, so that's what we're going to try to find now. We're just changing the letters around a little bit. We're given the angle on the side. So angle and side are always kind of like A. And then the other side that we're given, the second side, is going to be B. Okay, so that's what we're in general gonna try to solve for. If we're given some other letters, we might have to draw it out and solve for. So D. So what we're going to do here is we have 29 times sine of 67 degrees, and this is going to give us our minimum possible measurement. And so we have 29 times sine of 67. So that means that our side has to be at least 26.69 to match, 6.69. Okay, and our side length is 23. Okay, because it's less, that means that this triangle doesn't actually work. Okay, and I'm gonna, this is something that you don't necessarily have to do if you get a situation like this. I'm gonna put it in though. So this, what we're getting in this case here is, okay, there's gonna be our bottom. Okay, we're gonna have our one line, which is at a measurement of 67 degrees, or very close. Okay, and then our other line, okay, this line, try this again here. 57 degrees, roughly. It's pretty close. Okay, and then we would have our other line. So this is the one that we're trying to find. This is E. E is only going to go like that far. It doesn't actually make it all the way to the end. This entire distance would be 26.69, but we're only given 23. So because of that, we can't actually solve because we don't, it's not, this isn't long enough. Okay, and this one here is 29. And this was our angle E. Okay, so in this case here, we can't actually solve for it, which means that you're not actually going to get a measurement. So we can say that E is not long enough to create a full triangle. Therefore, there are no answers. Okay, there's no answers. Okay? Little e is not long enough, and so therefore we just do not have any answers. Okay, that is your answer. Okay, so as long as you've shown this here, okay, it's not no answer. E is not long enough to make this work. Let's try this last one here. let's get this one done. Okay, first things first, we want to double check, is this going to work? Is it not going to work? Okay, we don't want to actually go through with something if it's not going to work. You'll notice here, different letters. We have G, little g and big G. So then we need to figure out, is little g long enough greater than h times sine of big G? And h is 8 times sine of 50 degrees is equal to 8 times sine 50 equals, it's got to be at least 6.13. And you'll notice that 10 is definitely there. Okay, 6.13. So it is most definitely there. All right. Now this is a bit of a unique one as well, and I'll show you why in just a little bit. Okay, so I'm going to draw out this line tool tends to be a little bit delayed at times. And so we're going to draw 50 degrees it was. So here's my measurement of 8. And then here's going to be the measurement of 10. All right, just going to try to make this look a little bit nicer. Okay, so we're going to call that our measurement of 10. So we have this here is 8. This one here is 10. And this angle is 50. We're trying to find this angle right here. Okay, we can definitely do that. So what we're going to do is we're going to solve for that angle, and we're going to use sine law. So sine 50 degrees over 10 is equal to sine, this will be h over 8. And we're going to get that angle h is equal to 8 times sine 50 divided by 10. And inverse sine of the answer is 37.79, so 38 degrees. Now, if we see this, we would understand, so this one here is 38 degrees. We'd understand that we could draw another one, right? Because it does work for possible two. But because G is bigger than H in general, this other line here would not actually create that triangle. What you might notice is that the only way that this line here will reach is if it goes like that. Okay, it has to be, it's longer, and we can't actually put it in here like we would on this first one. So in this case, we actually only have the one measurement. We only have this one here. Okay, that's the only measurement that we have. In this case, it only has one solution. And what we're going to say here is that there's only one solution as side G is longer than side H. Okay, so because G is longer than H, we only have one measurement or one angle. So in this case, there's only one scenario. So we have to make sure that it could have two, could have none, could have one, and it could have one in a separate way where we are given exactly a right angle triangle. So be careful that we understand how many solutions there are, and we need to find every solution possible.